from geometry. I'm going to throw a little extra stuff. But if you have a right triangle, all right, your book says the reason you should learn this today, the many applications of right triangle trig gave the subject its name, which I don't really get what that means, but that trig was named because right triangle trig, I don't know, but anyway. But if you have a right triangle, so very important that it's a right triangle. If you want to find or relate the acute angles to the sides of the triangle, you can using trigonometric functions. And so it does not matter which angle we label theta. What matters is depending on what we label theta, how we label the side. Okay, so I'm going to take this angle to label theta. Because this is my angle, the angle across from that angle, I'm going to call the opposite side, because this is opposite my angle. Yes?
Yes.
Yes. And so I'm going to shorthand opposite by just OPP. You know me, right? Oh, you guys are too young to know that song. I don't know. I just know that line of the song. I'll look it up. I'm old. I'm not going to sing it.
You did a wrestling move
that was my younger days. The longest side, the side across from the right angle, is called the hypotenuse.
Oh, that's the word, hypotenuse.
Hypotenuse. I can spell the whole thing out if you want, but I'm just going to go HYP. I don't got a song for that one. If I said OPP to any person over the age of 25, they would say, "You know me." That's the song. And then this side. This is the side, not the opposite, not the hypotenuse. It's the one right next to it. So it is the adjacent. If I said look to the person adjacent to you, you would look to the person next to you. I'll spell it out. Adjacent. Make sure you know. One time I taught trig for a few days, and then one day someone said, "How come sometimes the opposite side's up here and sometimes the opposite side's down here?" And I realized there was a really big problem that they thought this was always the opposite side, this was always the adjacent side. But if this was theta, do you agree that this would now become the opposite side? It depends on what angle you are at. Okay, so make sure you pay attention to that. But if you have this, then you can talk about the sine, the cosine, and the tangent of that angle. And so we abbreviate these with these symbols, but do not say sin. It is sine. It's actually spelled like this. The sine of theta is the opposite over the hypotenuse. So whatever the opposite side is over the hypotenuse. Hence the SOA. Oh, sorry, SOH. The cosine. Do not say cos. Cosine, abbreviated COS, is the adjacent side over the hypotenuse, CAH. And the tangent, I have lots of jokes with these kids. I can't wait for you to learn this so I can tell you math jokes. Good ones. Tangent is opposite over adjacent. And so in geometry class, you should have learned good old SOHCAHTOA, because if you know that, then you know what all the sides are. But there are also three other trig functions that I don't think you learned about in geometry. Do you learn about these other ones? Yeah. These are the reciprocals of sine, cosine, and tangents. And so this is cosecant, which is actually spelled out like that, cosecant. Cosecant is the reciprocal of sine. So if you know sine, you know cosecant. You just flip it over. It is hypotenuse over opposite. Secant is the reciprocal of cosine. So it is hypotenuse over adjacent. And the easiest one to remember is cotangent, that it goes with tangent. And it is adjacent over opposite. Unfortunately, this doesn't spell out something cool like SOHCAHTOA. We try every year. This would be CHOSHACAHTOA. C-A-O.
That
Shoshakao.
sounds way cooler than SoCo.
Much harder to remember.
Shoshakao.
So don't try to remember. Don't try to remember that. Just remember, if you know sine, cosine, and tangent, you just flip them over. But you have to remember that cosecant goes with sine and secant goes with cosine. Not gonna lie, when I was in school, I remembered that it was opposite of what it seemed like to me, because it made sense to me. Why didn't cosine and cosecant go together? But they don't, and so I always remembered it was not the way it should be. So I probably just thoroughly confused you.
I think it's for
Sure. So on your homework today, they're going to give you a triangle. They're going to label an angle, and they're going to ask you to find all 6 trig functions. But wait, what's wrong with this problem?
There's no adjacent.
I can't do SOHCAHTOA or CHOSHCAHO. There's no side here. But what do I know about right triangles? What can I do?
Plus 2 plus Pythagoras. Pythagoras.
Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse squared will always equal the sum of the legs squared. And so if they only give you 2 sides of the triangle, Pythagorean theorem is what you're going to need to do first. If you don't get a nice number, if you get a square root, do not give me a decimal. Leave it as a square root. So, important that this is hypotenuse. So I'm going to say 5 squared plus b squared equals 13 squared. 13 squared is 169. I'm going to subtract the 25 over, and you get b squared equals 144. And you get 12. Why don't I do plus or minus? Because we're talking about the side of a triangle. The side of a triangle can be negative, so that's why you just know it's positive 12. If you know all 3 sides of your triangle, it's just plugging in all the numbers, and it just leaves them as fractions. So I'm going to say the sine of theta, and yes, you have to say sine of theta. Don't just say sine equals, sine of what? Sine of theta. Sine of theta, here's theta, opposite over hypotenuse is just 5 over 13. Cosine of theta. Cosine is adjacent over hypotenuse. Here's theta, so adjacent over hypotenuse, 12 over 13. And tangent is opposite over adjacent, which would be 5 over 12. Questions on where I got sine, cosine, tangent? Now you need to do the other 3. And again, for me, once I do sine, cosine, and tangent, I don't even look at my triangle anymore. I just flip them over. So I know that secant is the reciprocal of sine, so it's just going to be 13 over 5. Oh, look, I did it wrong, kids. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, which is 13 over 12. And cotangent is the reciprocal of tangent, which is 12 over 5. Because it's wrong. No. You have to say it right. I have a verbal quiz in here one day just to make sure you say it right.
Class, how do you...
Okay? That would be your answer.
That's like 6 lines of paper.
Or 3, just write them side by side.
That's still a lot of lines for one answer.
So what if I had this?
I can tell you what.
What if instead of giving a picture, they gave you one of the trig functions and they asked you to find the other ones? Can we still do that?
This is true too. Well,
You cannot say that.
why?
It's wrong.
And maybe in your opinion.
Right? So Grady's saying, well, if they give me sine, I at least know cosecant because I'm just going to flip it over and that's going to be 3 over 2. But I hope you don't just stop there and be like, well, at least I got 1 out of 5. That's 20%. Hooray for me.
That's actually you get credit for the second.
No, you only get credit for this because you do 5. found 1 and 5. What's the ratio for sine?
Opposite over hypotenuse.
Which means if they give you one of the trig functions, are they giving you 2 of the 3 sides of the triangle?
Yes.
So could I draw a triangle and label that and find the third side, then do Pythagorean theorem, and then do all the other stuff? Oh yeah.
You could, you just put the.
Does it matter which angle I call theta?
No. Yes.
It does not. It doesn't even matter if my picture looks terrible when I draw it. But what matters is you label it correctly. So I'm going to pick theta up here just so I can do something different. But if I put theta up here, it matters that the opposite side is 2, the hypotenuse is 3. If you label theta down here, you're going to have 2 here and 3 still there.
So the adjacent one is always going to be the other one that's the triangle.
Yes, the leg. Yes. So just like the last problem, I'm going to do Pythagorean theorem. Important that you remember this is the hypotenuse they give us, so don't take 3 squared plus 2 squared. You're actually going to take 2 squared, I just always call that b squared, equals 3 squared. That's just going to be 9 minus 4, which is not a perfect square, yes? Do not give me a decimal. We are going to call this adjacent side the square root of 5. So I'm going to do the exact same thing, but now think about when I do my SOHCAHTOA. Sometimes I'm going to have a square root in the bottom of my fraction. I don't like that, so we have to do the algebra to fix that as well. So we already got sine, we already got cosecant, so I'm going to start with cosine, and the cosine of this angle would be adjacent over hypotenuse, square root of 5 over 3. Is it okay to have a square root in the top of my fraction? Yes, good to go. Don't give me a decimal, ever, on a problem like this. On a problem like this. Sometimes with decimals. Tangent is opposite over adjacent, which would be 2 over the square root of 5. Do I like to leave square roots in the bottom of my fraction?
Yes.
No. What can I do to move that square root from the bottom to the top?
We'll flip it and call it the cotangent.
Multiply the top and the bottom by whatever's in the bottom, because that's just going to move it up. It's really multiplying by 1, so that would be 2 square root of 5, and on the bottom, that's just going to become 5, right? Because the square root of 5 times the square root of 5 is just 5. You're going to do this a lot. Pretty soon, you're just going to automatically do that in your head, because you're just going to be like, oh, I'm just going to move it to the top, and the bottom is going to become 5, or whatever it happens to be. And what else do I need? The reciprocals. So cotangent's a nice reciprocal, because, like Grady said, if we go back to what we started with, can I just flip that over and now make it the square root of 5 over 2? You could flip this over too, but then you got to simplify it again. I promise it works out to be the same thing. But if you ever have to do the work to rationalize it, go back to what it was first. It's much easier. And which other one am I missing? Secant. Grady, I'm going to start taking your participation points away every time you say it wrong. I'm going to give you negative participation points.
Participating.
Negatively. He's participating in a negative manner. He's doing it on purpose. Secant is 3 over the square root of 5, but I need to rationalize that, so really my secant answer should be 3 square root of 5 over 5. That's a really messy paper. So if this was your paper you were going to turn into me, at least circle those final answers for me, right? Like 1, 2, 3, 4, 5. Have some sympathy for your teacher.
I saw all of our questions.
So what?
All the questions.
Who needs a calculator? You're like, you have to have a calculator to do this next one. We're skipping this, going to this.
Special trip.
Who needs a calculator? If you don't have a calculator, you have to have one right now. On your calculator can do radians and degrees. Most calculators are automatically in degree mode. If you turn your calculator on, mine at the bottom has a little DEG. That means degrees. Some of them have a D. If you have RAD or R on your calculator right now, then you are in radian mode. when we have a test, there will be questions that you need to use your calculator. If you are in the wrong mode, you get the wrong answer, you lose points. So really important that you pay attention to what mode you are in. If you're in degree mode, on my calculators, if I wanted you to evaluate the sine of 16.35 degrees, you can just type that in your calculator. In degree mode, you just hit the sine button and it puts a parenthesis and you type 16.35. You don't have to put a degree symbol because the degree mode tells it that it's in degrees. And it gives you the ratio of that as a decimal. And 4 decimal places. All right, you want to be you want to use a lot of decimals to be as exact as possible. And so we would round that to 0.2815. Did anyone not get 0.2815? If you have a different calculator than me, you have to figure out how to change your mode. And if you don't know how, you're going to have to see me after class to do that. But on my calculator, the button right next to seconds that says DRG, you just hit that, and it comes up DEG, RAD, GRD. We never use G. Yeah, I think so, but we never use that. So if you want to change the radian mode, you just arrow over and you hit enter, and at the bottom now you can see that it says RAD. Some calculators just say R.
So how do you get to CS?
So how do you do cosecant, secant, and cotangent? There are no buttons like that on your calculator.
Is it sine -1?
It is not sine -1. You have to think about that this is the reciprocal of the 1/3.
It's going to be 1 over 1.
Well, this is a different number, but if this is the reciprocal of sine, do you agree that cosecant of an angle is the same as 1 over sine of that angle? Reciprocal, isn't that what reciprocal means?
So like sine.
So if you see secant, cosecant, or cotangent, you have to do 1 over the sine of 3 in radian mode. I cannot help you type things in your calculator on a test, so that's why you have to make sure that you do these and see me if you have. Don't leave. I'm holding you hostage.
Yeah, I didn't get that. 1 divided by sine.
You have to be in radian mode. 1 divided by, don't use the fraction button, 1 divided by sine of 3 in radian mode. I think I need to change some homework, so hold on. Don't leave. You can,
Oh, wow.
we did not talk about the special triangles today, so that has to go to tomorrow. 3 through 18, SOHCAHTOA, and its reciprocals. 30 through 40 are using your calculator. So if you don't have a calculator, you'll have to get one or come in early and borrow one of mine, okay? Goodbye.